Okay. Questions? Can you hear me better now?
Yeah, now we can hear you clearly.
Okay, cool. Okay, let's see the a couple more people will show up.
How have you been, Dr. Gondanu?
I've been very busy, extremely busy.
Shoot, I can imagine.
I'm exhausted. It's crazy.
That's how work has been here at the dairy. Thing is thing is hectic out here.
Really?
Yeah, they're making us cut down on milk.
Oh yeah.
Uh, farmers are getting paid. Well, some farmers are going to get paid less. Some aren't getting their milk picked up. People are getting fired left and right from dairies. It's just crazy.
Yeah, that's well, you have to. That's if you cut by cutting, you are saving yourself. So that's what you want to do. Okay, so I posted the it should be there now, or it's posting. It takes some time.
It's posting. It hasn't came
Yeah,
up
okay.
yet.
Yeah, it's there now. So the chapter book is there.
Okay.
Okay, so if you go, you should be able to see it. Is it? Of course, it's going to be at the end, but I'll move it to the top. Okay, so the chapter PDF is there. All right, so that is good. Um, so what I want to start with is just really to um, to summarize what I put in my videos, because I mean, really, if you just watch the latest video I recorded, there's nothing really much more that I have to, to teach you. So, what is the objective of this class? Okay, so, oops.
Dr. Gondanu, I have a question.
Yes,
In the course, in the course materials, you said
yes,
that there's three lecture videos, but there's only see two. Is the other one on YouTube?
yeah, they are all on YouTube. I keep on telling you in every
Okay.
single email message to go on YouTube.
Okay. Making sure because I seen those two.
Yeah, I mean, because uploading them on Blackboard was taking a lot of time, but I'll try to do that again. So class objectives, one, derivatives. Okay, so go back and practice taking derivatives because we need them to develop our production functions. Two, production function, okay, and total cost, and four, profit function. So our production function, one example is x plus 6x squared minus 0 0.0, no, 0 0.3. Um, let's see. Usually you have a third. I'll put that. So this production function represents something like this. Okay. Um, I need to move this somewhere. Huh? Okay. And so what are we trying to find out? Okay. We're trying to find out, well, okay, if you are producing, right? So maybe here, at first, uh, you have rapidly, oh no. Okay. At first, you have a rapidly increasing, okay, output when you are adding input. So let's talk about feed and milk. Very simple, right? So the cow is starving. When the cow is starving and you give, let's see, well, and you feed the cow usually 10 pounds, okay, it's usually not enough, and you get this amount of liter. So 10 pounds, you get 20 liters from the cow. If you feed the cow just 5 pounds more, right, you may get 30 or 35 liters. So you can see that, okay, your output increases much faster than your input. That's what we call an increasing return to scale. Now, from here, we call that an inflection point. An inflection point, okay? And from here, things go a little bit more slowly, okay? It's decreasing return to scale. So what we are trying to find out is this point here, okay, at the top of a production function. Why? Because this is where you need to understand as a producer that you want to reach, okay? So over here now you see that I put what, 45, okay? And here is, no, it's here, right, this function, okay? And 50, there you have, let's say 18 to 20, okay? So as you go up, you can see that when you add a small quantity, or let's say 5 units of input, okay, this here to here is 5 units of input, what you get in return is maybe 2 units of output, right? So you start with 5 and you get 15, increasing return to scale. Then you add another 5 here, but you only get 2, okay? That is decreasing return to scale. But now what is the key here? The key, as far as you are talking about productions, you are just looking out what's the maximum I can possibly produce, how much milk can I possibly get from this cow, right? I'll be saying, well, I just want as much milk as possible. So even if I had to dump in 10 pounds additional, okay, to get only 1 liter of milk, then if my objective is to maximize my production, I will do it. Does that make sense?
Yeah.
Right? So even because my goal is to produce as much milk as possible, right? So even if I had to, force feed the cow 10 more pounds and to get just 1 liter of milk, I'll do it because I want to have the highest possible. And now the question is, okay, how do I get this point? How do I know what this point is? So let's say that the maximum here is, I don't know, 22. Okay. The question is, how do I know what this point is? Well, I will go back. I'll remove some of those things, okay, to make things not so. It's not going. Okay. Going to erase and start over here to make it clean. All right, so I drew, so I drew my production function again. Okay, so I want to get to a highest level, okay? So with the derivative, we also learned the slopes, okay? And those were in my first 2 lectures on derivatives notation in chapter 1 all those things, right? And so that's why I show you, okay, how do you take derivative for different functions, product of functions, quotient of functions, all that. I hope, you get it. So the derivative, so the slope at a function at one point, okay, is the derivative of that function, right? So when I take the derivative of this function here, then it gives me the slope, okay? So I can plug in different point and I'll get the slope. So I will take the derivative, okay, d of y over d of x. And that means that when x increases by 1, y increases by, when x increases 1, y is going to increase by x number, right? So if this is my derivative here, and this gap here is 1, and this gap here is 2, then I know that when I increase x by 1 unit, my y increases by 2 units, okay? And so here I'm going to have 2. That's what the derivative tells me, right? By how much I can improve milk production for my cow if I feed the cow 10 more pounds of feed? That's the question, okay? And obviously, what I want to figure out is at which point, okay, the cow is producing as much as she possibly can. In that case, I want to set the derivatives to be equal to 0 because I'm looking at this point here, right? I'm looking at the maximum point. And so at this point, the derivative is 0 because this is the slope at that point. Does that make sense?
Yeah.
Okay, so I take the derivatives to find this maximum point on the production function. I take the derivative of this function here, right, which is equal to 1 plus 12x minus 0.9 x squared. There we go. And then I say, well, this derivative, for me to find the maximum point here, I need to say it equal to 0 because that's what it is. Okay, and so here now I have a quadratic function. And so these points, x that only found here, is going to be equal to, I think is equals to plus of minus b to the power b squared minus 4ac times 2b. All right. So on my function here, what is what? That's what I want to know, right?
Yeah.
What is a? So
A would be, oh, sorry.
So if I rewrite the quadratic function, if I rewrite this function, okay, I'm going to rewrite this, then it's going to be minus 0.9 x squared plus 12x plus 1, right? So so this is going, no, where is it? Yes, this is going to be my a, the coefficient of a square, the coefficient of the x is going to be my b, and this is my c. And so I'll just plug them in. So my x is going to be equal to, so b, what is b? B 12, right? To the power 12 squared minus 4, a times c is, well, minus 0.9 times 1, okay? Times 1, so that's the same thing. And I divide all those things by 2b, which is 2 times 12. And you solve this. It does give you this point here. Okay? Hello?
Yes, sir.
Is anybody there?
Hello?
Yes, I'm here. I'm just writing all the notes down.
Oh,
Yes, sir,
okay.
I'm here.
I'm going too fast?
No, I just can't write fast enough.
Oh, okay, sorry.
No, you're
I'll give you a break. Just
no,
let me know when you're almost done, okay?
no, just don't worry about me.
Okay, so I'm going to clear everything and then we'll, all right. So that is the first thing. Okay, we have our production function. This is the maximum output. So this is Y, this is X, this is X. Well, this is really, yeah. I think this is one, not sure. We have our maximum production function here, okay? So when I'm looking at my average, and then, so we have the concept of production function. That's what I just covered, okay? 1, 2, I need to cover of marginal physical product. 3, the concept of average physical product. Okay, so the concept of marginal physical product, okay, so marginal physical product. Marginal in economics means, you know, plus 1 unit, right? Is a change in my output divided by the change in my input, right? So again, if I change X from 2 to 4, okay, how much Y am I going to get? Okay, so if I get Y 10 to 30, so you can see that here I have a 20 when I only include 2. But if I take the percentage, okay, will tell me that on this stage here, I have an increasing return to scale because the percentage will be positive, right? I get a whole lot more output in percentage than the proportion of input that I include. So here, from each additional unit of input, I get 15 units of output. So that's the reading here. Okay, that's what marginal means, right? If I change my X by 1 unit, how much more Y do I get? And so to get that, basically, I'm getting the derivatives over here at this point, okay? And the derivative at this point is just what we found earlier. I think the example I took was Y equals, no, X plus 6X squared minus 0.3X cubed, right? Okay. So this derivative of this, so that's the same thing as marginal physical product, again is equal to 1 plus 12X minus, no, 3.9 it's 27 actually. This should be 2.7. 2.7. No. It is 2.9, 333, okay. Minus 0.9x squared. So this function here, okay, is going to be the derivatives at each level of x. So if I plug your x in, okay, so if x equals 2, right? So here, x equal 2, the question is, what is going to be the derivative of a production function at this point, right? And so I'm going to plug it in, it's going to be if x equal 2, then f of x, so that means f of 2, okay? Or if it's same as f of 2, and this is the same as y, okay, is my y, okay? Y is always a function of x, and that's what I have here. This production function y is y equals f of x, because I'm finding how much output do I get when as a function of input, okay? And so that's going to be equal to 1 plus 24 minus 0.9 times 4. right? And so if I compute this, it will tell me, well, when X is 2, okay, well, I should have Y here, okay? And there I'm going to have my slope. So now the next concept I need to know is just, well, okay, what about the averages? So, and so let me finish with the marginal physical product. So the marginal physical product will look something like, so here, my marginal physical product is going to cross this here. Why? My marginal physical product tells me that as I'm increasing input, I'm also getting more output, right? But when I'm here at the maximum, right? Okay. So I'm going to erase again, okay? So my production function here, okay. So here is my maximum. So let's say is 50. And at 50, I'm inputting 20 unit of input. If I increase the unit of input to 25, okay, what do I get? I'm here. I'm get an output that is maybe 48, correct?
Yes.
And so how do I translate that here? Is the marginal physical product. It says then when I increase my X, right, I get a negative additional output. That's why this curve, marginal physical product, okay, crosses, becomes negative, right? My Y becomes negative, decreases as I'm increasing out input. Is that clear? So at the maximum product I can get, okay, my marginal physical product equal to 0. Right? Okay. And look at here. Which function is this? Sorry, which function is this? Anybody? Which function is this? It is my marginal physical product, right?
Yeah.
And I said, when my marginal physical equal to 0, then I know that I'm producing the optimum. So to find the maximum output, okay, I just have to set my marginal physical product to 0. It is same as setting my derivative to 0.
Let's just find the top of that, or the maximum output.
You let me know if I'm going too fast, okay?
Oh no, this is fine. I'm just finding the maximum output you can get out of a given.
Right, the maximum output you can get out of a given
or
crop or animal is to a point where as you feed more of the animal, okay, the next you need to feed the animal, she doesn't give you more milk. And if you force to feed her, then she will be saturated, she gets sick and she will produce less milk. Of course, you don't want to get there. And so that's our stage 2. And so in stage 3, a production function is where you don't want to be, in any case, right. Okay? Because here, of course, you are spending more money to have less good. I mean, who want to be there? It doesn't make sense, right? Okay.
So our goal is to figure out just to stay in at least stage 2.
Correct. The goal is the optimum stage.
Preferably the upper the upper part of stage 2.
Correct. So what is that upper part? That's the question now, right? That upper
That's
part
what-
of stage
that's
2
what we're-
is when the average physical products crosses the marginal physical products. I'm just trying to see, just have an idea but to graph everything correctly. Okay, that's one way. Okay. So when is that point? At this level here, okay, I have my inflection point. So this point here is the inflection point. And that's what tells me the beginning of stage 2. Okay, so what does that mean? This level here, what does that mean? You can see that here, okay, I have an increasing return to scale. Correct? As
Yes.
I am adding more units, 1 unit, I get more output. So that's why my marginal is increasing, right? Because it's showing that as I'm giving 10 pounds, I get more output than 10 pounds. I give another 10 pounds, I get even more from the cow, okay? But proportionally more. I get to a maximum, and that's here. This is the increasing return, sorry, to scale, okay? So this stage 1, or down here, is increasing return to scale. So obviously, this is dull, right, okay? You don't ask yourself any question. And when you get here now is a decreasing return to scale, right? And here, as I am adding input slowly, right, my output is decreasing. It's still positive, right? So this is, I give 10 more pounds and the cow gives me less than 10 pounds. I mean, 10 more pounds of feed and the cow give me proportionally less milk. Let's say 5 pounds of milk. But as long as I'm getting more milk, then I keep on producing, feeding the cow. Or when I get here, the guy say, okay, I'm out. Okay, I'm busted. If you give me more, I'm going to pull it out. Whatever. Okay, but I will not give you more milk. This is it. And so the cow get to its limit. Right. First, you have a starving cow, a happy cow that is giving more and more and more, and when she's at the limit, she gives you less, less, and less, less. So that's why I have an inflection point, right?
So
The marginal physical product is at its maximum. And
So
so
what you're saying is like the point where it's worth it that you're feeding the cow and it's still giving you a profit, basically.
no, this is not profit.
Oh, okay.
Not yet, because you cannot talk about profit if you don't have a cost.
Oh, okay.
Right? Okay. I think I'm going to stop this and reload it because I have 40 minutes every time. Okay, so I'll go about 5 more minutes and then I will, let me do it now, okay? I'm going to close everything, shut down everything, okay, and reload it, and you guys do the same thing, okay?
Okay.
I'm not going to upgrade anything, so let me stop sharing. So we clear everything, come back. And meeting.